Hello, everybody. Today we're going to be talking about the acceleration due to gravity. And to start it off, we're on day 2.3 right here. So you'll be seeing this video right here. But it starts off with a mini lab. And this mini lab is basically an opportunity to kind of review this process that we've had. But I'm going to take a few moments and I'm going to do this lab basically with you, or so you can see it, because people are making a few mistakes. So the first thing is kind of analyzing what's going on here. So basically, in free fall, something is falling. Now, this technically isn't exactly what happens, but we'll talk about that later. So let's say you jump out of an airplane or you drop a ball off a building. After 2 seconds, this was the different trials to see how fast it was going. And then after 4 seconds, and after 6 seconds, after 8 seconds. So basically, it's the amount of time after dropping a ball off a building or jumping out of an airplane, something where gravity can take a hold of it. So the first problem that I've been seeing in some of the lab reports and is that the average, this average should only be of these trials. Now in this case, there's 4 trials, but sometimes there's 3, but I'm gonna go ahead and do these real quick. So I have 20.0 plus 19.2 plus 20, use my keyboard, 20 plus 19.2 plus 20.8 plus 19 equal sign divided by 4, 19.75. Also on the homeworks, if you just double click on these right here, you can just go, oh, bam. Now, if I look at these technically, 3 digits, 3 digits, 3 digits, 3 digits, this should also be 3 digits. Uncertainty is the largest minus the smallest divided by 2. Largest is this one, smallest is this one. So I have 20.8 minus 19 divided by 2. So I have plus or minus 0.9. Cool. Same one for these ones right here. I am, just because I need to make this video under 10 minutes, I'm not going to worry about the uncertainties for these. I am just going to be doing the averages. So 39 plus 39.8 plus 38.3 plus 41.0 equals, and then divided by 4. And I get 39.5. Okay, next set are these numbers right here. 57.4 plus 59.6 plus 58.5 plus 59.2 equals, divided by 4, 58.7. And then this final one right here, I have 79.5 plus 77.3 plus 79.1 plus 77.8 equals, divided by 4, 78.48. Okay, or sorry, 78.4. Cool. So now what I'm going to do is I'm going to open my Desmos link. Now this is a little bit different, and before in Desmos, we would always put the independent variable here and the dependent variable here. Well, here's an exception. Whenever there is time involved, time is always going to be on the x-axis, okay? So, and actually that's how this is set up. So my time falling is 2, 4, 6, 8. I got that from this right here. And my velocities were 19.8, 39.5, 58.7, and 78.4. Ooh, looks like you can't see that last one very well. So I'm going to zoom out a little bit. Okay, bam. Now my uncertainties, I'm going to say my uncertainty is 1. Just, I was lazy to do it, but there you go. Okay. Doesn't look great, but okay. Now my C value, I'm gonna get this. I'm gonna see, ooh, can I get a quadratic out of it? Not really. Can I get a linear though? Ooh, I can pretty much get a linear. Look at that. That's a pretty good linear. And if I look at it, I'm like, ooh, that mark right there, it does not look right. All right, and that was my second one, this one right here. So I bet I didn't calculate this correctly. I bet I made a mistake. I can even go back and check it real quick. I can say, hey, 39 plus 39.8 plus 38.3 plus 41 equals divided by 4, 39.5. Oh, sure, that's fine. So that data point's a little off. Whatever. I get 9.8. So what I would do is I would do a screenshot of this right here. I would actually do it so you can see I would move this a little bit. So you can plus or minus and move stuff around. But I would take the screenshot so you can get the titles right here. That, bam, that made a screenshot for me. Cool. I can say that this right here is linear. The corresponding equation is I look over here, and it's for this one right here. V equals C times T. That comes from this part right here. My C value is 9.8. And my equation with the C values, I basically take this and I input it into the C here. So it'd be V is equal to 9.8 times T. And when you double and we're gonna go with time, when you double the time, we're talking about velocity will, and it's linear, so it'll double as well. Cool? Cool. So that's that. The main point of this whole thing actually is to get this C value. This C value of 9.8, that right there is the acceleration of gravity on Earth. Okay, so what does the C value stand for? The acceleration of gravity on Earth. Okay, and if you look it up, if you say Earth's gravity, bam, 9.807. Okay, so that's what we were solving for right there. Now the last part is we basically take that information and we solve some equations for it. But this is the process of physics in this class. We gathered some data, okay? We found out the relationship. We came up with an equation. We even came up with a constant, and then we use that to predict other results, okay? And this right here, this is an example one that shows the work. Another thing I noticed on the homework is this answer right here is the main one that I'm checking. Make sure that this one right here has the correct units, okay? That's all I have for you today. Please let me know if you have any questions at all, and I will talk to you later. Peace.